Unit 1, Calculus, Day 7 notes. First theorem of investigation that we're going to study is the intermediate value theorem. I'm going to write it down. Intermediate, I always think of intermediate swim lessons. There's advanced, there's beginner, and then in between is intermediate. Okay, so we have a graph here, and we have the interval a to b including a to b. So if I know f of x is continuous, now first off, if I know this is point A, then over here I have f of a, the y value when x is a, and then therefore this is b, so this point on the graph is f of b. What I'm going to be able to conclude, first off, I need to know that y is somewhere in between f of a and f of b. Now, it doesn't matter if f of a is bigger or smaller. So I've shown both scenarios where y is bigger than f of a but less than f of b, or y is smaller than f of a but bigger than f of b. So what we know is that there's going to exist at least one value c somewhere in here. As long as y is between a and b, there's going to be a value on the x-axis c that's also in between a and b, such that f of c is going to equal y. Let me show this on the diagram. So here's our y value. Doesn't match up exactly. Sorry about that. And this is our intermediate value theorem, which for shortcut we may do IVT. So now we want to look at these graphs to determine if the intermediate value theorem is applicable to these functions for the given intervals, for the values given. So is there a value of c on negative 5, 2 such that f of c equals 2? So let's first put the interval. So I'm going from negative 5 to positive 2. So somewhere in here, is it equal to 2? And let me just change that. So yes, right here, that's equal to 2. And again, they're saying, is there value c? So we can now say yes, and I don't know exactly where, but I'm just going to put c is somewhere between negative 5 and negative 4. So as you said, yes, c is somewhere between negative 5 and negative 4. All right, let's answer the next question. Does the intermediate value theorem guarantee a value of c such that f of c equals 2 on the interval from negative 5 to 2, which I haven't read here? Why or why not? Well, going back to the definition of the theorem, f of x had to be continuous. So no, the intermediate value theorem does not guarantee a value of c on the interval negative 5 to 2 because the function f of x is not continuous on this interval. All right, let's look at the second example. So the second example, piecewise function, and it's asking, is there a value of c on the interval from negative 1 to 5 such that the value of the function f of c equals 2? So, and I'm putting a dotted line up there, and what we find out is that in order to be, if we were going to have f of c equal to 2, then no, there's nothing up there. And so to answer the second part, does the IVT intermediate value theorem guarantee a value of c such that f of c equals 2 on the interval from negative 1 to 5? Why or why not? Now, even though it's continuous, so if I look all the way between here from this value all the way down, it's continuous. But what I find out is f of c, which is 2, is not between f of negative 1, which is right about here, and f of 5. F of 5 down here is there. So 2 is not between those two values. Okay, so does it guarantee a value? It is continuous, but remember the y value, or in this case f of c, has to be between either between f of a and f of b. So next, what two conditions must be true to verify that intermediate value theorem? Well, we just talked about it. It has to be continuous, and then f of c must be between. So let me write those down. So now what we're looking for, so the two conditions continuous, it must be between two values of f of a and f of b. So for each of the functions, determine if the intermediate value theorem is applicable or not, and state why or why not. So if it's applicable, find the value of c guaranteed to exist by the theorem. So for 1 and 2, we'll notice we have the same function, and as I quickly look at this, I see that it's undefined when x equals -2. So as I look at the first interval, it's from -1 to 3, okay, and the next, and that does not include the -2, so it's going to be continuous. I'm going to write this down in a second. And the second one's on the interval from -4 to 1, which contains that undefined value when x equals -2. There's a vertical asymptote there. So let's write that down. So as we said, the first one is continuous. So we'll move on to the second condition. But the second interval from -4 to 1, -2 is in that interval. So therefore, the function f of x is not continuous. Therefore, the intermediate value theorem is not applicable for f of c equals 2/3 on the interval -4, 1. So now let's go back to number 1. We know that it's continuous, so now we got to check is f of, in this case, f of c between f of -1 and f of 3. Oops, I didn't mean to have you watch that whole part. So all I'm doing is substitute in and finding the values of f of -1 and f of 3. So taking our original function, find f of -1 equals -4, f of 3 equals 0. And I know that f of c equals 2/3, and that's not between -4 and 0. So therefore, the intermediate value theorem, or IVT, is not applicable for f of c equals 2/3 on the interval from -1 to 3. Okay, so trying to meet the two conditions. Hey, the first one was continuous, but then the value of the function was not in between -4 and 0, so therefore the intermediate value theorem is not applicable. On the second example, it wasn't continuous, so we were done right there. I'm going to skip number 3 and I'm going to jump down to 4 and 5, and then when we come into class, we will be able to talk about all these. All right, so let's do number 4. I quickly look at this. The function x over x minus 2. I see that there's going to be a vertical axis at 2. Hey, that's not in the interval, so it's going to be continuous. Second condition is that the value -1/2 is going to be between f of -1 and f of 1. So I'm going to find those now. If I find f of -1 equals 1/3, f of 1 equals -1, I know that -1/2 is between those two values. So therefore, the intermediate value theorem is applicable for f of c equals -1/2 on the interval from -1 to 1. And now I need to find out the value of c guaranteed to exist by the theorem. And now we're going to solve for the value of c, which is going to be guaranteed to exist because of the intermediate value theorem. So from our original function x over x minus 2, I'm going to say, I replace c and x, I'm going to substitute in c. So c over c minus 2, we knew f of c was equal to -1/2, so I'm going to set this equal to -1/2. I have a proportion, so we're going to use the means extremes cross product property. So 2 times c is 2c. -1 times c minus 2 is -c plus 2. Let's bring all the c's to the left side. get 3c equals 2. Solve for c, divide both sides by 3. So c equals 2/3. And that's guaranteed. That's the value between a and b um, because it's continuous and the value of the function was in between the values of the function of the interval. Okay, the last one here, number 5. I know that this is an exponential. It starts as decay. There's 2 reflections, so it's still going to be a decay, but that doesn't really matter. We know all exponential functions are going to be continuous. So condition 1 is met. As we said, all exponential functions are continuous on the interval from negative infinity to infinity. So let's look at the next condition. We're going to try to find the value of f of 3 and f of 5 and see if negative 4 is between those. So negative 3 plus 3 is going to be the 0 power. 1/2 to the 0 is 1. There's a negative sign out front, so we get negative 1 minus 2 is negative 3. Second one is, well, negative 5 plus 3 is negative 2, so 1/2 to negative 2 is the same as 2 squared, which will be 4. So we end up getting negative 4 minus 2, and that's negative 6. And I'm looking to see, hey, is this in between? Negative 4, yes. Negative 4 is between f of 3 and f of 5. As we said, f of c equals negative 4. That's between f of 3 and f of 5. So the intermediate value theorem is applicable. And now we can find the value of c, which is guaranteed to exist by this theorem. And again, intermediate value theorem, we said between, or it's between this. That's what we're looking for. So every place we saw the original function, we substituted in c for x. And we're going to set it equal to, because we're saying f of c equals negative 4. So now we want to solve this. How do I do this? I first undo subtracting 2 by adding 2. So I end up with this. And now how do I undo multiplying both sides by negative 1? We're going to divide both sides by negative 1. So it's going to make that positive. Um, now what we're going to do is go back to some of our logs. And I want to now take the log of 1/2 of each side. So log base 1/2 of 2. That's really saying 1/2 to what power equals 2, and that's going to be negative 1. Nice thing here, we have this exponent. I know our properties of logs. We can bring the exponent out front. And I forgot that it was negative x plus 3, so I got to put a negative value there, a negative value there, which will put a negative value there. Okay, and that's, again, the properties of logs will help us solve this exponential function. So now we just solve for c, and let's bring all the numbers over to the right. Negative c equals negative 4. Divide both sides by negative 1. C equals 4. Okay, so by the intermediate value theorem, I know c is guaranteed to exist, and its value is 4. And I wrote all over it. C equals 4. Okay, we'll take a look at number 3 in class, and any questions on any of these that we just did. All right, good job.